Shri Gurubhyo Namaha. Good morning, children. Hope you are doing good. Today, in this third part of Atoms and Molecules chapter, we are going to learn Dalton's atomic theory. Matter has been one of the most important subjects of research for the scientist. Scientists and philosophers have always tried to simplify things. They wanted to know about the fundamental particles that makes matter, their properties, structure, etc. This led to the formulation of a number of atomic theories. Dalton was the first man who proposed that matter is made up of particles. He named these particles atomos, meaning indivisible. This was the Democritus atomic theory. Due to the lack of technological setup back then, scientists had very limited information on this theory. After 2000 years, the works on the simplifying matter was materialized by scientist John Dalton. In 1808, John Dalton postulated the famous Dalton's atomic theory. He published this theory in a paper titled A New Chemical Philosophy. Indeed, the philosophy was new for that era. Dalton presented his atomic theory to explain the properties of matter. Dalton's atomic theory of matter became one of the foundations of modern chemistry. Dalton was the first to calculate the masses of atoms of several elements. Postulates of Dalton's atomic theory. The matter is made up of indivisible particles known as atoms. The properties of all the atoms of a given element are the same, including mass. This can also be stated as all the atoms of an element have identical mass, while the atoms of different elements have different masses. Next one, atoms of different elements combined in fixed ratios to form compounds. Atoms are neither created nor destroyed. This implies that during chemical reactions, no atoms are created nor destroyed. The formation of new products, that is compounds, results from the rearrangement of existing atoms, that is reactants. Atoms of an element are identical in mass, size, and many other chemical or physical properties. But atoms of two different elements differ in mass, size, and many other chemical or physical properties. So, these are the postulates of Dalton's atomic theory. However, this theory is not entirely free of limitations. Let us now look at the drawbacks of this theory. It was proved that an atom is not indivisible, as an atom can be subdivided into electrons, protons, and neutrons. But remember that atom is the tiniest particle that takes part in the chemical reaction. Dalton's atomic theory, atoms of an element are identical in mass, size, and many other chemical or physical properties. But practically we observe that atoms of several elements differ in their densities and masses. These atoms with the different masses are known as isotopes. For example, Chlorine has two isotopes with the mass numbers of 35 and 37. Also, according to Dalton's atomic theory, atoms of two different elements differ in mass, size and many other chemical or physical properties. However, this is also not correct for all the situations. For example, argon and calcium atoms each have an atomic mass of 40 atomic mass unit. These atoms with similar atomic masses are isobars. And also, Dalton's atomic theory fails to explain the existence of allotropes. This implies that Dalton's atomic theory fails to explain the differences in properties of charcoal, graphite and diamond. These are the allotropes of carbon. Atomic theory also suggested that an atom is the smallest part of an atom that can take part in the chemical reaction. Some postulates of this theory remain valid even in today's modern chemical thoughts. Learned about Dalton's atomic theory. We will meet in the next video, children. Thank you.